Okay, here we go. Okay, so again, it's the study of the relationship between triangles. But to study that relationship, you got to start somewhere. Where do we start? Let's talk about angles. Okay, so here is the beginning. Angles are sometimes formed by two what? Rays. On the coordinate system with a common vertex at the origin. Now you can put angles anywhere, but in our class we will make it really simple. We'll put our vertex where? Right on the origin. So the vertex of your angle, to make things simple, keep it at the origin. There's a side, there's a ray, called the initial ray or the initial side. Stationary, it doesn't move, usually on the positive x-axis. So I would call this the what? The initial ray. This is the one we're not going to move. The one we're going to move is the other ray. We call it the terminal side or the terminal ray. Okay? The ray located after a what kind of move? Counterclockwise or clockwise rotation. So if I go this way, oh, by the way, this would be considered what ray? Terminal. This is the one where you move it and then you stop somewhere. If you move this direction, it's known as what direction? Counterclockwise. But what that really means is you went which way? Positive or negative? Since you went up, think of up as what? Positive. This is a positive angle. Counterclockwise is positive. Clockwise is what? Negative. So if you go this way, guys, okay, that's the terminal side. This is a negative direction. The way I like to think of it, instead of saying clockwise or counterclockwise, I just say, if I start here on my x-axis and I go up, that's what? That's positive. If I go down, that's negative. I mean, that's probably easier than thinking counterclockwise versus clockwise. Any questions? No? Okay. So if I were to label this, let me just say this. Let's make this up. What do you think that looks like? What degree? 30. 30? So we call this what? Positive 30. Let's call this one what? Negative 30. Good? Yeah? I mean, we're making that number up. It could be negative 27. Who knows? But that's basically how we are going to attack angles. Okay, so would you please do me a favor and just sketch. It's just a sketch. You're not going to be perfect. I'm not giving you a protractor. Just show me what a 70 looks like. And then after that, show me what a negative 240 looks like. You just got to be in the right ballpark. I don't think the 70 gave you much trouble. Maybe the negative 240 did. I don't know. Okay, 70. Like I said, you got to be in the right ballpark. So if you went like this to me for 70, yeah, no. What do you think? Am I going to give you credit? No. Because okay, you got to realize all the way straight up is what? 90. That is a 90. Straight up is 90. So you're 70. So where's the middle? Yeah, the middle's 45, right? If that's 45 degrees, your 70 should definitely be somewhere like that. Wouldn't you say? Okay, so what I would hope you did, I hope you did this. You have to show me the direction you turned. You turned which way? Up, because it's positive 70. Is that good? If you don't put that arrow, I went that way, then how do I know if you might have went that way for 70, and that's not 70. Okay, so let's do the other one. Here, I'll draw it like this. Okay, so here's your angle. Here's your initial. Where's this going to go? Which way? Up or down?
Down.
Down. Where am I at right now? No?
Negative 90.
Yep. Okay, negative 90. Keep going.
Negative 180.
That's negative 180. Got to get a feel for this. How far is this?
Negative 270.
That's negative 270. You went too, whoops. You went too far. So then you got to think, okay, 240. How much past 180 are you?
60.
How much?
60.
60, right? You're 60 degrees past this, so you have to kind of say, well, when do I quit?
Past halfway.
Past halfway. Am I halfway right now?
About there.
Okay, so I got to go a little further. Would you call that good?
Sure.
Okay,
Why not?
this is 200 what? Negative 240. Now, how am I going to know you're right? Because guess what? Not all of you are going to land there. Matter of fact, I think I might have went a little too far. I think I did. But here's the deal. I would pretty much, I'd like it if you're in that area. But to be honest, some of you are going to end right there. You're going to end there and get it wrong. Unless you do what? You tell me this angle right here. How much farther past 180 did you go? Did you go 60? So if you would please just tell me you went 60 past 180. Or maybe some people go, well, yeah, but Mr. Painter, I went 30 short of that. So that's okay. Just give me something. Because I'll be honest with you, 80% of you are going to land right there. Then there's going to be 20% of you. That's 1 out of every 5 of you will land here. That's wrong. Unless you tell me what? That number. That number, by the way, is called the reference angle. It's like between the terminal and the x-axis. Okay? Yes? No? Good? Okay. All right. Ooh. Radian measure. All right. Ready? Radian measure. Somebody out there just tell me what it is.
Measures essential angle theta that intercepts an arc as equal to the
No. In your own words. In your own words.
I got it.
Okay. Oh. Zach, go ahead.
Is that how many times goes around the circle?
How many times 8 goes around the circle? 8. Who's it?
Theta.
Theta? No.
Beta.
You guys, you dealt with radians for 2 months in LGT. You're not going to tell me
That
what.
was a long time. It was last year, but it was still long.
I know what it is, I just don't know how to explain it.
Yes, Zach.
Is it the length of the initial ray? No?
Oh, is it the length of the arc on the circle that's like, okay, so there's like the angle in the circle and then in between the angle points is the radian?
So here, I'll give you an example, right? See this? This is your initial side. This is your terminal side. I want the measure between here and here in not degrees, in what? Radians. She's so close. You said the distance of what?
I was like the outside part, like that.
That's called the arc.
Yeah.
Okay, so it is. She's right. It is the distance from here to here. It's the distance. But you gotta tell me, what does it mean? Radians.
How much of 180?
Okay. How about if I tell you this? I'll tell you this. What I just drew to you, I drew you 1 radian. That was 1 radian.
Oh, it's 45 degrees.
But what does that mean? Okay, nobody's saying. Okay, ready? Here's what it is. If you take your radius R, if you could lift it off the paper and wrap it around your circle over and over and over, that's what a radian is. 1 radian, right here, this is one radian. It's the length of your radius. How many times are you wrapping around your circle? Just once. So where would 2 land? Just curious if you know. 2 would land, yeah, double it, right about here. That's 2 radians, right? Where would 3 land? About here. 3 lands here. 4 here. 5 here. 6 here. Oh, I fell short. It's more than 6. A complete circle is more than 6. A half a circle is more than 3. You want to make a guess. How far is it for half a circle? Right here. It's okay. Somebody saying you guys are saying pi. But yeah, you know what it is? How many times can you wrap your radius around the circle to get here? 3.14, or better yet, what? Pi. You know what this measurement is from here to here? How far is it from here to here? No, not 180. You gave me degrees. In radians, it's how far? How far is it from there to there?
Pi r.
Pi. No, just say pi.
You said
It's-
pi.
But what I'm saying is this. You either tell me 180 or you say pi radians. And pi radians, all it means is you take your radius and you wrap it around your circle. How many times? 3.14, or just say what? Pi radians. Okay, so a complete circle is 2 pi. Or roughly 6.128. Yes? You know what I'm going to ask you on a test? I'm going to say, what quadrant does 5.1 radians fall? Where's 5.1 radians going to fall? You're going to say, what, Zach?
Quadrant 4.
Yeah, because I already drew you a 5 here. 5.1 radians would land right there. That's what it is. It's just how many times you wrap yourself around the circle. And when I say how many times, how many of these radius can I wrap around the circle? So can you have this? 75 radians?
Yeah.
Is there such thing as 75 radians?
Yeah.
Yeah. What if I asked you where this lands?
Divided by pi.
Divided by what?
You divide it by pi. See,
Well, why wouldn't I do 2 pi? Because, like, if that goes in there evenly, I'll land right on the x-axis. I'm going to let you think about that. Don't worry about that for right now. Okay? Do you get what a radian is? What's 1 radian?
Right.
1 radius
Radius.
wrapped around the circle. It's right here. So when I say, what's this angle right here? You can say 1 radian, or you could say
Pi.
57 degrees. That and that are the same thing. This one says degrees. This one says what? Radians. Kind of weird, isn't it? But that's what you were doing last year. You were wrapping radius around the circle. Okay? Okay. I gave you too much information. This should be an easy slide. How many radius lengths around the circle? How many of these can I wrap around?
2 pi.
1, 2, 3 would land here, 4 would land here, 5 would land here, 6 would probably land here. And you said what? 2 pi, which is 6.28 radians around the circle. Okay, guess that.
Can we just say 2 pi or just
Yeah, don't say 6.28. Don't do that. I'm just telling you how many of these can you wrap around there? 2 pi. 6.28. Okay. Since 1 radian equals 1 radius length, 360 degrees, a complete circle equals how many radians? 2 pi. Good? Okay, next. Common reference angles in radians. Okay. Will you do me a favor? Just try your best. Try your best. Would you graph it? I haven't told you hardly anything. I'm not sure if you can do that, but maybe you can. Will you graph 5 pi over 6? Probably a couple ways you could tackle this problem. I'm kind of curious what you do. I was hoping, I'm sorry I didn't say this, I was really hoping you would not use your calculator. So if you use your calculator, shoot. I have to tell you, there's a non-calculator version of your test. There's a calculator version of your test. This stuff that you're doing right here, non-calculator. Huh? Okay, I'm ready. Are you ready? Tell me how you found this angle. Go ahead, Tommy.
Divided pi into 6 parts.
Divided pi into 6 parts. Where's pi?
180 degrees. So
Okay, so here's pi. So you say all the way over to here, this would be pi radians from here to here. And you said break it into 6 parts. 1, 2, 3, 4, 5. Ooh, 6. That's not very good. Hang on. 1, 2, 3, 4, 5. Okay? And then you have how many of them?
6 30 degree angles.
6 30 degrees. You don't have 6 30 degrees. You have, what'd you have, 5? 1, 2, 3, 4, 5. I would say
yeah.
this.
Oh, yeah, and then you multiply 30 by 5.
Oh, that's how you did it. Oh, I thought you were just going to look at your pieces of pie.
Oh, no.
So 1, 2, 3, 4, 5. I have 5, 6 pi. I thought that's where you were going. He's doing this. He's saying that every one of these is what? 30 degrees, right? Then he says, well, if pi over 6 is 30 degrees, he multiplies it by 5 and gets what? Isn't this 150? Yeah. Okay. Okay. So did you get it or not? Or did you do it a different way? Yeah, how'd you do it? Emma?
I found the reference angle, so
That's what I was going to show everybody, but go ahead. Keep going.
okay. So like basically you have 5 over 6, so you have like 1/6 left, which you could say like pi over 6, and then I guess just from last year, like I know that that's equal to 30 degrees, and since pi overall is 180 degrees, just go back. Like,
You went back 1/6. Okay. She knew. Okay, the way I hear you, you kind of knew you were short of a pi by 1/6. So then you went pi and backed up a 6, and you're right here. Okay. You know what, guys? Here's the way I do it. Kind of like Tommy, kind of like Emma, but here's what I do. I go like this. You know what pi is?
180.
180. I take 180, divide by what? 6. What do you get? 30. And then I do what? Multiply by 5. I knew I had a what? I knew I had a 150. Okay? Oh, by the way, that's not what we're talking about here. We're talking about, what's the word up there? Reference angle. That's okay. We're talking about the reference angle, and Emma has already said the word reference angle. Well, here's the reference angle. You will draw many, many angles, but the reference angle is the terminal side. The terminal side, and what do? You go from here, and you go right back to the x-axis here, back to the origin. This triangle is what you're going to look at over and over and over for the next 2 months. Okay? And by the way, this is the reference angle right here. It's what? It's 30 degrees, or in radians, it's what? It's pi over 6. You could say 30, or you could say pi over 6. I will tell you this is pre-calc. In pre-calc, they go into radians a lot. So I hope you can get your mind to think radians. It will take time. Okay? But that's all a reference angle is. So you might want to do this. Write the word, this is my reference angle. My reference angle will become more and more important in the next few weeks that we're here. Good? Or should I go back? Okay, what's this? You're going to be asked several times. Give me the coterminal angle. Oh, well, what's a coterminal angle? 2 angles which have the same what? Initial and terminal side. So they're trying to tell you this and this are what? Coterminal. Now, let's check it out. What does a 30 look like? Draw yourself a 30. That's about a 30. Would you agree? Okay. Now they're trying to tell you if you draw a 390, a 390 will have the same initial and terminal side. Is that true? Let's do it. Let's draw it. Here we go. Here's a 390. I messed up. 30 looks like this, doesn't it? That's a 30. What's a 390 look like? Once around is how far? 360. And how much more? Whoops, 30 more. So is this truly equal to this? So I could tell you 390, or I could tell you 30. It's the same way. It's the same angle. It's got the same initial and terminal side. Okay? So now you give me one more. No, and use this angle. Somebody give me another one. That means 30 or 390.
Negative 330.
750.
Okay, Zach says a 750. What did you do to get that, Zach?
I multiplied 360 by 2 and added 30.
Oh, okay. I thought you'd just say I added another circle to the 390. You can do that too, yep. He did it slightly different. Sophie, what'd you get?
Negative 330.
She gets negative. Watch this. She's going this way. She's basically saying a negative 330 is the same as a 30, which is the same as this, which is the same as this. Are all four right?
Yeah.
Yeah. So what are we doing to get those answers? Add 360 or subtract 360. So you will be asked to do this. How about that? 2/3 pi. Give me the positive coterminal, give me the negative coterminal. Okay, let me go down below. Is there anything? Oh, yes, there is. A general rule would be to find a coterminal angle, just add or what? Subtract what? 360 or, put the or there, please. Or what? 2 pi. There you go. You want to just add a circle or subtract a circle. Okay, go to your next slide. Let's do this one. Do 2/3. It'd be really good if you graph it. It just would. So make a sketch. Did anybody do this? Did anybody do pi is just 180? Divided by 3, it's really just what? 60. 2 times 60 is what? Do you guys know that 2/3 pi is just 120? Okay, so you drew it, I hope, right? So you went like this, 120 about here, correct? This is 2/3 radians. Not 120, I just 2/3 radians. Okay, I want another coterminal angle. One of them positive, one of them negative. So I'm going to go like this. What's the positive answer? What's the negative answer? Okay, tell me.
8 pi over 3.
Oh, you're just going to tell me the answer. Will you show me how to do it, or just say it?
I just added 2 to the 3 and then put pi on top.
You took 2/3 pi, then you did what?
Added 2 pi over 3, which would be 6 pi over 3. So you reduced it.
Oh, okay, gotcha. Now, she's adding a 2 pi, a circle. But then she's getting the common denominator, right?
6 pi over 3.
Yeah, she's changing her denominator from 1 to 3. And this one she doesn't change. This one she changes to 6/3 pi. Would you agree? Okay, what's the answer? 8/3 pi. Okay, what does 8/3 pi look like? It's just this. That's 2/3 pi plus what? 2 pi gets me right back here. Yeah. But what's the negative version of the answer? Yeah, Zach.
Just do 2/3 pi minus 6/3 pi. function, you would get -4/3.
-4/3 pi, yep. Which, if you think about it, -4/3 pi would be here, and then go which way? That way. That's -4/3 pi. Yeah? No? Okay. This answer, and that original answer, those are all the same angle. They're called coterminal. Should we do the next one or should we skip it? This is what I'm talking about.
Skip it.
Skip it? You sure?
Yeah.
Anybody got an answer? Just, yeah, tell me what you have.
Positive is 5/6 pi.
Negative, answer is what?
19/6 pi.
Is he right? Well, you'd add 12/6 and get that. You'd subtract. Yeah, he's right. Write them down. Just write them down. Go do them later. For people that want to do them, go do them later. Can we move on? Go on. Go on. We got to get here for sure. This is our last slide. I'll go back. Okay? You ready? We need to convert. Sometimes you want to work with radians. Sometimes you want to work with degrees. Well, we'll go from degrees to what? Radians. Or we'll go from radians to what? Degrees. Okay? How do we do it? Well, we do it the same way we did. How do we change feet to inches? How do we change meters to centimeters? We just use conversion rates. Well, look at this. This is kind of nice. If 2 pi radians is equivalent to 360 degrees, then pi radians is equal to what? 180. Okay, so make sure you get that on paper. Right here, because this is what you're going to use when it comes to conversions. You'll either use this one, 180 degrees over pi, or pi over 180. So this is your conversion, right? Okay, but which one do you use? Well, let's do this. If you want to convert 300 degrees to what? Radians, then you kind of have to know, if I want degrees to become radians, where do I put the radians? Do you want the radians on top or the bottom? On top. Because you want the degrees to do what? Cancel out, yeah. So you must do this. Radians on top, well, that would be this one, right? Pi radians is equivalent to how many degrees? 360. That's the way you want to tackle this one. Okay. What's going to cancel? What's going to cancel, guys? Degrees. Those units are gone. Now you're in what? You're now in radians. Okay, ready? 300 times pi is 300 pi. Over what? 360. Of course. Ah, yes, you're right. Sorry. Good catch. Good catch. 180. Cross that out. Okay, this is 180. My fault. 180. Okay, you know you're going to reduce it. What goes into both? What? 6?
Yeah.
Okay. When two numbers end in a 0, what do you think? 10? 10 goes in here 30 times. 10 goes in here 18 times. Now say it. Now what goes in both? 6. 6 goes in here 5. 6 goes in here 3. The answer is what? 3. 5/3 pi radians, right? Good? There you go. All right. Now you got another one. Take that radian measure, -2/3 pi, and change it back to degrees. If you want degrees, you put degrees where? On top, yeah. You want radians on the bottom. Pi what? Pi radians. 180. Try not to make that same mistake I made. Okay, let's do some canceling. What cancels? Oh, you know what? The radian measure is right here. It doesn't say radians, but it is. Radians, radian, pi, pi. Now what? Multiply this, and this is 1, I guess. So this. So it's negative 360 over what? 3, which makes negative 120. I have said this. There's a non-calculator, right?
Yes.
Version test. This is non-calculator. Almost everything I'm doing today is non-calculator. So if you've been punching your calculator, not good. Okay, it's not good. You need to be doing this in your head. Okay? Back. Is that it? Or one more. One more. Okay. I saved this for last because if you didn't get this today, it's okay. But now we have time. Okay. So you can measure degrees with decimals like this. 48.56 degrees basically means what? 48 and how much more? This much. 0.56 degrees. So you can get in between degrees, okay? So when you get in between, you get that funny decimal. Okay, so as a decimal. Or you can use what? Minute, degrees, minutes, seconds, which means the same as that. Okay? This is used in story problems when they talk about a plane. You're in a plane, you're flying a plane, you turn the plane, whatever, minutes, seconds. Or you're in a ship, you're sailing your ship, and you make a direction change. They use minutes and seconds. Well, hang on here, because 1 degree is supposed to be equal to what? 60 minutes. So what if I turned my ship 30 minutes? That's half a degree. Just half a degree. That's all I did. Okay. And then, of course, there's 60 seconds in a minute. We know that. Okay.
So then
So-
why did they call it hours? Why are they degrees? If 60 minutes is 1 degree, can't it just be an hour?
Could be, I suppose. But it's so much easier. Degrees are 360, so that's why it gets weird. Our circle is. Okay. Anyways, so this, if you read it to yourself, it's 48 degrees, 33 minutes, 36 seconds. Okay? Here's how you do it by hand. You ready? How many degrees do I have? 48. I'm trying to get this back to this up here. I'm trying to make this. 33 minutes? Well, 33 minutes, there's 60 minutes in an hour, right? So you'd have to add what? 33 minutes out of 60 minutes. So like what decimal part of a degree did I turn? And then plus 36 what? Seconds. Oh, this is how many seconds? Remember, 1 hour is 1 degree. How many seconds are in an hour?
Oh god, 360.
360. A lot more than that.
Oh wait, 3600.
3,600. Okay. So if you punch, guess what you get? You get that. So I'm just trying to tell you this because you're going to read problems. And when you read these problems, you're going to go, what? I turned 22 degrees in 13 minutes and 12 seconds? What the heck is that? Oh, it's just this. It's right here. That is that. Okay. But, do you have to do that every time? Nah. You may do the conversions using what? Your calculator. Let's do it. Okay, this one. 134.81 degrees is equivalent to how many degrees, how many minutes, how many seconds? Oh, my calculator can help me out. It's cool. Oops, don't look. Clear. Okay. Here we go. Type it in. 134.81. 134.81. I want to know, can you convert that to minutes and seconds? Well, here's how easy it is on the calculator. You go basically to this button called apps. What's the word above apps?
Angle.
Angle. Second, angle. And you want
EMS.
DMS, degrees, minutes, seconds. Hit number 4. Hit enter or whatever you have to do, I guess.
Whoa.
And it comes out right there.
Heck, that's cool.
So 0.81 is equivalent to 48 minutes, 36 seconds. Okay? Write that down. I'm not going to write it down. Did you see how I did it? I went second, apps, because the word above app is angle. Okay, let's do the next one. The next one says, you turn your ship negative 20 degrees, 16 minutes, 40 seconds. How do we get that back to a decimal? Okay, well, here we go. Negative 20 degrees. How do I tell it degrees? Go back to second, angle. Oh, number 1, degrees. What? I don't know. How many minutes? 16. How do I tell it minutes? Second, angle. Number 2 is what? Minutes. Okay. How many seconds? 44? 40. 40 seconds. Seconds are really hard to find. Every year I do this, I gotta go look for them. They're right here. See the plus sign? Look above your plus sign.
Oh my god.
To the right, in green is second. No,
Then you
or is
use
that second?
alpha.
Is that seconds?
Yeah.
Yeah. So you go alpha, the green button, then the plus button, and there it is.
Why?
Now that is degrees, minutes, seconds. I want the answer in decimal form. Hit enter. Am I making you do this by hand? No.
Thank you.
I just wanted you to see it. Okay. That's it. I think, right?